Recall that a translation moves all points of the original figure the same distance in the same direction. Both side lengths and angle measures are preserved. So for part B here, we're going to look at these two triangles, DEF and D prime, E prime, F prime. We're trying to determine if this is a translation. So I have redrawn this onto my paper, and you can see I've connected each of the corresponding points, and we do in fact have what looks like the same length lines between them and that they are parallel. So we're going to walk through and compare these distances, compare these slopes, and determine that this is a translation. So first we're going to look at the distances. We want to compare the distance from D to D prime. Plugging in our points into the distance formula, we find that it is 2 square roots of 5. From E to E prime, plugging in those points using the distance formula, we see that it is also 2 square roots of 5. And plugging in the points for F and F prime, we see that again, it is 2 square roots of 5. So the 3 pink lines here are in fact all the same length. These segments are all equal. Next, we're going to look at the slopes. The slope of DD prime is 1/2. The slope of E prime is 1/2, and the slope of F prime is 1/2. We can figure that out by looking at our rise over our run. We're going up 1 over 2, 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 up 1 over 2. So they are in fact all the same slope, which means that they are all parallel. Because the criteria for a translation are met, triangle D prime, E prime, F prime is a translation of triangle DEF. Use the coordinates of one vertex and its image to find the translation vector. Let X, Y, inside of these carets, represent the translation vector. So we have E, which is at the point 5, 5, right here, and it becomes E prime at 1, 3. So to figure out what our movement is, we have to figure out 5 plus what is going to give us 1, and 5 plus what is going to give us 3. So in our expressions, we have 5 plus 1, x, 5 plus x, 5 plus what equals 1, which is, in fact, -4. So that means that we are moving to the left 4. And 5 plus y equals 3, that is -2. That means we're going down 2. So our translation vector is represented by the component form -4, -2, telling us that we are going to the left 4 and down 2. To the left 4 and down 2. And lastly, we can just double check that using this more colorful version of our drawing here. Back 4, down 2 is in fact the vector that we are using.